to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
Hi, I'm the Casual Spaceman and welcome to my channel once again. We all know with flat earthers the biggest sticking point is gravity, and they've come up with all sorts of different theories about what exactly gravity is, or what the force is that keeps us on the earth or makes this pen drop. And we've had all sorts of different ideas, relative density and buoyancy, but the most recent seems to be electrostatic energy or electromagnetic energy. Now, I recently came across a premiere by BM Furball, who manages to completely dismiss this idea using an instrument that not many of us have access to. So watch this video all the way to the end, because that's where he gives the smoking gun. So without further ado, BM Furball, take it away.
In the flat earth world, there is one scientific fact that believers must account for with some other form of explanation, and that is gravity. In recent months, there have even been arguments within the flat earth community of whether a downward force is required in their model or if buoyancy and density alone account for all downward acceleration.
Do you think that in order for relative density to work, there must be some sort of force present?
No, I think a change in disequilibrium can create forces.
Okay, all right. Well, I'm not going to argue any further with you.
One proposal for this downward acceleration has been electrostatics, and that is the topic of today's video.
Now, I do believe in a force that holds things or that creates the density table. That's called electrostatic force, Coulomb's law, and I'll talk about that later on, but not here in this debate.
Me personally, my position on this is that there is no such force. There is no such thing as gravity the way that we're told. I'm open to the idea that there could be some extra, some like electromagnetic effect, perhaps ethereal. The spitball inside of it, I'm fine with.
So let's move on into the point where I think that it may have something to do with an electrostatic or electromagnetic type of argument, okay?
First, what is electrostatics? Electrostatics is a branch of physics that studies the differences in electric charge between bodies at rest. Specifically, the study of the imbalance in the electric charge on the surface or within the material. This imbalance results in an attractive or repulsive force between objects that all of us have experienced on a dry winter's day. Electrostatics is referred to as such because of the non-fluctuating nature of this charge, as opposed to electric current that continuously flows between the charges. And it is this continuous charge that results in the attractive and repulsive force we observe. This charge can flow between the objects under the right conditions, but after equilibrium is reached, the attractive and repulsive force no longer exists. As most know, static charge can be easily added to certain types of material to cause this force. By adding a static charge to materials such as plastic, you can do some fairly magical things, such as making your hair stand on end, moving cans without touching them, bending water, and even making things appear to float in midair. It isn't hard to see how someone who doesn't understand the science of it could view static charge as the cause for gravity. Even the mathematical principles that govern electrostatics appear very similar to gravity. In the 1780s, French physicist Charles-Augustin de Coulomb studied electrostatics extensively to determine their physical properties that govern their interactions. Coulomb's work was the basis for future developments into electromagnetic theory and the development into what has become known as Coulomb's law. This law states that the force we observe is equal to a constant known as Coulomb's constant multiplied times the charge of the two different bodies divided by the radius squared. This formula may look very similar to anyone that has researched gravity. As you can see, both have a constant value, and both directly compare the properties of these two objects with their distance. The principles of gravity and electrostatics are very similar, specifically due to the inverse square law. This states that a specified quantity or intensity is inversely proportional to the square of the distance between the objects. You can directly observe this while playing with electrostatics in your home, as the reaction of the force you are imparting drops quickly with distance. The major difference, however, is that the effects of the Earth's gravity is from its center of mass. This is the reason why you can't feel the effects diminish as you get higher up on a mountain. You're experiencing a fractional decrease. On the other hand, while you're observing two objects with electrostatic charge, the decrease is directly observable. This was the point that Team Skeptic was trying to address with JM Truth.
The last question, okay? The last question is F equals ma, and F equals the gravitational equation now is going to be big G times m1 times m2 over r squared. Now we can rectify that equation and come up with the equation that acceleration equals the gravitational constant times the mass of the Earth divided by the radius squared. So that's why all things fall at the same rate. Now, can you do the same thing using Coulomb's law? If you're going to use Coulomb's law as the electrostatic force being the responsibility for the reason why mass accelerates towards the ground when dropped, how do you rectify that with those two equations? Because you should be able to do that. We can do it with the gravitational equations. It's impossible. It's impossible.
Just because you're saying it's impossible, you can make it impossible.
Well, this is all very educational, but you know there has to be a point to it. Well, let's pretend that electrostatics is the cause of the downward force. But there's a catch.
So, Mandelbrot just asked this question for JM about electrostatic force, if you think that's what gravity is. Wouldn't putting an object in a Faraday cage then negate the electrostatic force causing gravity?
So what is a Faraday cage? A Faraday cage is a shielded enclosure that blocks electromagnetic radiation and electrostatic charges from interacting with objects inside it. The property was first discovered by Michael Faraday in 1836, when he was experimenting with cork and electrostatics. Faraday noticed that if he hung cork from a string and put it inside a can, he could not make the cork move via electrostatic forces. Here is a very dramatic demonstration of how a Faraday cage works to block electrostatic interaction.
And you see Mr. Franklin there getting a little bit uncomfortable. You see his hula skirt streaming out behind him as he is in right now in quite a large electric field. As you can get a sense there, he's not so happy at this point. Maybe I'll turn it up even higher. There you see, well, I've got a lightning bolt going to my grounding rod, and as you can look at what's happening to Benjamin as the lightning bolt hits the grounding rod. There you go. Benjamin is not happy. So now what we're going to do is we are going to have the same thunderstorm, the same electric field, but we are going to put Benjamin in a Faraday cage. Now, if you look, you can see that there's lightning hitting the cage. There's that lightning bolt going from the Van de Graaff right to the cage here. And you can see that the cage has a very considerable electric field on it by looking at the tinsel over here on the far side, which is streaming out behind it just like the tinsel on Benjamin was before. But now look inside at Benjamin in there, and I have to be careful not to touch the cage. But now look inside at Benjamin in there, and his tinsel is completely motionless. Benjamin is completely comfortable in there, calm, at rest, while the lightning storm rages around him, literally around him, and that just got me.
So if the downward force on a flat Earth is caused by an unknown electrostatic force beneath our feet, then that force should be diminished or altered by placing an object inside the Faraday cage. While I mentioned that Faraday cages also block electromagnetic radiation, that means cell phone signals. And wouldn't you know it, I have a Faraday cage. This is a forensic Faraday cage used to examine cell phones that have been collected as evidence in criminal investigations. By placing a cell phone in this box, you block out virtually all electromagnetic waves and electrostatics. That means that if electrostatics is the cause of the downward force, placing something inside this box will break the connection between those objects and diminish or completely remove the downward acceleration. So let's do some experimenting. What we have here is a drug scale, a test weight, Han Solo and carbonite, and my cell phone. We start by turning on the scale and ensuring that it is at 0. Now let's move to the cage. We place all the items in the cage and seal it tight. Then watch the signal on my phone. After a few moments of confusion, the phone gives up and says there's no service. Now know that I am also 4 feet away from my home's wireless router, but the cage completely blocks it. Now let's check those weights again. And wouldn't you know it, not even a fraction of a gram off. But let's not end there. Maybe the diminishing electrostatic force in the cage prevents my phone's accelerometer from knowing which way is down. Nope, we don't see anything there either. So, flat earthers, you can mark this one off your list of excuses for the cause of gravity. Or you could just accept that gravity is real and stop arguing the semantics of if it's a force or a pseudo-force, or whether it's mass attracting mass or the warping of space-time. Because Einstein did not replace Newton. Trust me. Now, next week, we're going to continue this conversation on the warping of space-time and how it was observed on the human scale. I'll see you all next time.
Well, I hope you enjoyed that video as much as I did, and I think it's a great demonstration as to how we can actually dismiss electrostatic energy as the force that keeps us and this on the Earth and this pendulum dropping. Well, if you haven't done so already, please go and subscribe to BM's channel. Link is in the description, and a link to the original video is in the description as well. So please go there and like and share the video and make a comment. So that's all from me. I'm the Casual Spaceman, signing out.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.